Hi everyone, welcome to today's class. Today we are going to talk about SQL joins. A SQL join clause is used to combine rows from two or more tables based on a common field between them. The most common type of join is SQL inner join, or we simply call it a join. A SQL inner join returns all rows from multiple tables where the join condition is met, right? So in SQL, join is used to actually join two or more tables. So using joins, what we do is that we combine two different relationships to find some matching record between them. And then joins are of different types. The most common join, or which we also call as natural join, is the SQL inner join, which would only give the matching record or matching result set between two tables, right? So let's talk about the inner join first. The inner join keyword selects all rows from both tables as long as there is a match between the columns in both tables. SQL inner join syntax is like this. We select the column names from table 1, inner join table 2 on. So whenever we write a join statement, there has to be a condition, right? On which condition you want to join these two tables. So that condition is what we give with the on keyword. So using on keyword, we tell SQL Server that this is the condition on which I want to join these two tables. So instead of writing inner join, you can also write join, and that would mean the same thing to SQL Server. That means either you can write join or you can just write inner join. And then after that, you have to give the condition. So let's see that with example here. So for example, we'll again go to the AdventureWorks 2019 database. So first of all, I'll write select star from, I'll write human resources dot employee and I'll give it a name. This is the alias. We have already talked about alias in the past, so that's why I'm not going into detail. Then after that, I'll write inner join, or we can write join as well, simply. Both would mean the same thing. And after that, human resources dot employee department history. I'll give it a name EDH. And then after that, I need to give a condition on which we'll join these two tables. So I'll put the on E dot business entity ID equal to EDH dot business entity ID. So I'm joining these two tables. On which column I'm joining? I'm joining the matching column, which is the business entity ID. So whatever business entity ID would be there in both the tables, that is what going to uh, on the basis of that, we are going to combine the result set and we are going to get the data. Now let's go to again and let's select here few columns so that you also understand that when you are joining this two tables together, then how to select appropriate columns. So here I'll select few columns from the employee table. So E dot birth date, E dot gender, E dot business entity ID, E dot job title. Maybe these four columns I want from here, then EDH dot department ID, EDH dot start date, EDH dot end date. So these are the columns that I want from these two tables. And that all records should come on the matching of this business entity ID column. So the syntax of this inner join or any join is like this only. You join the table A, inner join table B on, you put up the condition. This is what we do. Here the condition can be multiple as well. Right now, we are putting up condition only on just one column because again, business entity ID is the primary key of the employee table, right? So if you join on that, that is fine. But sometimes we need to put up the multiple conditions. So in that case, I would write another condition like and then I would put those other column that on which I want to put the join condition. Now, if I execute this query, we'll see that we are getting some result. right? And this is the combination of all the data from this two table. Now what I see here is that I'm getting 296 records here, right? So instead of getting 290 rows, which is the initial number of rows in the employee table, I'm getting 296 rows. So let me again run this query against human resources dot employee table only, just to show you how many distinct records we have in this table. So you can see in employee table, we have 290 records, right? Let's go and let's run this query against employee department history, human resources dot employee department history. So in employee department history, we have 296 records, right? Some of the records here are duplicate, and that's why, like, some of the records are not duplicate, but it's actually there for two times. And that's why we are getting in total 296 records. We are combining this table to this table on the basis of some column. Let me quickly find out which is the column which is actually having multiple values. So count star underscore business entity ID, group by. Don't forget about this query that I'm running right now. We will understand this query later on because this is out of the scope right now. I'm just trying to say, check something for my mind. Okay, so these are the business entity ID which has duplicate, which are actually there two times in this table. Human resources dot employee department history. For example, I'll run a query against one of these. So I'm running for the business entity ID 4. You can see that there are two results for the business entity ID 4. What is the difference here? So this particular employee has worked into two different departments, department ID 1 and 2, and then there's a start date and end date of this. So the start date for the first department is this, end date is this, and the start date of the second department is this, and the end date is this. So this is how he has started and worked on this, right? So let's go back and let's again talk about some other joins. So we have just talked about the inner join. Now, similar to inner join, we have other joins as well, which are known as the outer joins. So in outer joins, we have three types of joins. Let me write it down here. So in inner join, we have just the inner join thing, and then in the outer join, we have three things. One is the left outer join, or we simply call it left join. Similarly, we have right outer join, or we can call it right join, and then we have full outer join, which we can call as full join. So these are the three different type of outer join. Let's try to understand each one of them. So the left join keyword we use. So the left join keyword returns all rows from the left table with the matching records on the right table. The result is null in the right side when there is no match, right? So as the name suggests, this is a left join. That means the left table becomes the main table, and we'll get all the data from the left table and only the matching record from the right table, right? So suppose that there are two tables. When you are using the left join to join these two tables, then from the left table we'll get all the data, while from the right table we'll get only the matching data. And for those data which is not matching in the right table, we'll just get a null placeholder in place of that, right? So for example, here, just to explain you all, I think it would be better that we create our own table. We insert some data, which will actually help you understand the differences between all of them. So suppose that I'll create two tables of my own. One, I'll create the employee, right? Then employee department. So for example, let's create the table employee. This will also help you to just revise through how do we create tables and all. So create table employee empid in ename varchar 20, then designation. Let's suppose that we have three columns in this table. Then let's create another table, and I will keep this as identity 1 1, and then also I'll create this as a primary key column. So I'm creating the employee and the department. So through this purpose is to know that which employee works in which department, right? So this is what finally I want to know from this query. Now here I'll create the same constraint like this. Here I'll write employee department, and then this will be on the department and DPTA. So the first query it's successful. Sorry, the first table. The second table is also successful. Now I'll insert some data into this two tables. So insert into employee values. Then maybe I'll just put some random name A and the designation engineer. And similarly, let me copy paste this 3 4 times. I'll give it another name B and label C 8 B. Again engineer. So this way I've inserted 5 different records into this employee table, as we have kept the employee ID as identity column. So that means I'll get the and also the value start with it and goes with one increment. So it will be like 1 2 3 4 5 employee ID. Now I have to insert in the employee department table. I'll use the same way to insert into the employee department table. Here for this value, I'll insert 1 and insert 3, 4. Right now we don't have a foreign key setup between this table, but normally in the normal scenario, what you will see that we'll have the foreign key relationship setup in between this two tables. Once we have the foreign key relationship set up between these two tables, then you want to be able to insert this value into the employee department. Why? Because if there's a foreign key in this table on the employee ID column, so then SQL Server would be able to allow only those columns inserted or those value insertion into the employee department table for this column employee ID, which employee ID already exists in this employee table, right? So as of now, I know that 6 doesn't exist in this employee table, so this value would not be allowed. But the purpose of this particular example is not to show you that, but I want to show you the different type of joins. And that's why I'm keeping it like this, so don't get confused with that. So now I'm going to insert this 5 value to this table. So I've inserted this value as well, right? Now let me run across some queries. So first of all, let me fetch the data from all these two tables. That means the employee table, and then what is the name of the second table? Employee department. If I select both data from both the table, you can see that I'm getting some values, right? So here on the what basis I'd be joining these two tables. Suppose that if I have to join the matching column between those two tables is the employee ID. We have the employee ID in both of them, right? So on the basis of that, I'll join these two tables. So first of all, let me show you the inner join. So select star from employee E inner join depart employee department ED on E dot empid equal to D ed dot empid. So if I get try to get the data, what we can see that I'm getting only the values for the employee ID 1, 2, 3, and 5. And again, if you see, there are two times we have the employee ID column in this result set. Why do we have two times here? Because we are using the star. That means we want to fetch all the columns. So the same column, even if it's there in both the table, it will be represented twice. So that's why we have the employee ID two times here. Now, one of the interesting thing is that we are not able to find the employee ID 2, right, which is just there in the employee table, and then also the 6, which is just there in the employee department table, right? So that is the condition, that is the situation in which you'll be using inner join when you want to get only the matching record from both the tables. Now let's move forward and let's talk about left join now. So here, just to inner join, I'll change it to left join. So I have changed this to left join. So the definition of the left join says that all the matching records, all the records from the left table and only the matching record from the right table. That is the situation in which we'll have the left join. So let me run this 4 queries again. So what we see here is that I got, because employee table is the left table here, employee department is the right table here, and we have the left join. That means we'll get all the data from the employee table. So you can see as part of this result, I'm getting all the data from the employee table and only the matching record from the department table. So what are the employee ID we have in the department table, which is there in the employee table as well? These are the 4, right? We have 1 there, 2 there, 4 there, 5 there. We don't have 6. So that's why if you see the employee ID from the department table, we have just 1, 3, 4, 5. The interesting thing here is that the employee ID 2 that is not there in the department table, right? And that's why for that we are getting this null placeholder. So as per the definition of the left join, you'll get this null placeholder for only those records which won't be there in this right table, right? So that is the purpose of the left join. The next thing that comes here is the right join, right? So let's go and let's learn about the right join. So I'll use the same query because it will help you to understand the differences. So let me run this same query again. I'll put a right join. So now when we'll use the right join, what will happen now? So now the right table would become the main table. So in the previous query, left table was the main table. Because we are using the right join here, the right table will become the main table. So let me run this query now. What I'll do, I'll just run this 3 queries to okay. So in the inner join, we just got 1, 3, 4, 5 because those were matching. In the outer left outer join, I got 1, 2, 3, 4, 5. If you see now in right outer join, I'm getting 1, 3, 4, 5, and then null. This is from the left table, and this from the right table we are getting 1, 3, 4, 5, 6, right? So the right join is actually the opposite of the left join, right? So in the left join we have the left table as the main table, while in the right join we have the right table as the main table. So that's the major difference between the left join and the right join. And the other thing is that any non-matching record in the left table will be displayed as null. So as you can see, for 6 employee ID, we don't have any values in the left table, and that's why that is being represented as null. Any questions so far? Okay. So let me now talk about the full outer join, right? So we have talked about the left join, we have talked about the right join, we have talked about the inner join. The other type of join is the full outer join, which is actually the combination of the left join and right join. So whatever results that we get from the left join, whatever results we'll get with the right join, if we combine both of them, then we get the full outer join, right? So let me run this query now, just for you to understand, and then we'll go to the explanation. So this is the result of the full outer join. Now, if you see, this is the result I got from left join, right? We had for 2, we had null, null, null. The same thing you will see in the full outer join. This is the result of the right join that we got, where for 6 employee ID, I'm seeing null, null, null in the left table. So for the 6, we have the null, null, null in the left table. And we are actually covering all the employees ID here. If you see from the left, we are covering 1, 2, 3, 4, 5. From the right, we are covering 1, 3, 4, 5, 6. And the value which is missing in the left and right, that is being represented as null. So this is known as full outer join. This is the example of the full outer join, right? So now we are getting all the record set, whether it's matching or not matching from both the tables, right? So this is the situation when we have the full outer join. I hope this is clear to everyone. The next thing that we are going to learn about is the union operator. The union operator is used to combine the result set of 2 or more select statements. Notice that each select statement within the union must have same number of columns. The column must also have similar data type. Also, the columns in each select statement must in the same order. So the syntax of the union statement is like that you use select some column name from table name, and then union select some column name from table name. So union is used to combine result set from two different tables, right? So there are some restrictions of union. One is that the column that you use in the union keyword or the union sentence, in that you have to use the same data types in both the columns, like with from the table 1 and the table 2 on which you are doing this union operation. In both the table should the column that we are using, they should have the same data type. The number of column also that we are using in the union has to be the same from both the table. It is not like that in the upper sentence you use 4 columns, in the lower sentence you use 3 columns. That will not work. So for example, I want to get all the employee IDs. Whatever employees IDs are there in the employee department, whatever employees are there in the employee table, I want to get the combination of all the employee IDs. Suppose that we want to get that, so we can do that with the union sentence or the excuse me. So that we can do through the union operator. Now let me run this. So select employee ID or EMP ID from employee, right? And then union select EMP ID from employee department. If I do that, I'll get the combination of all the different employee ID which is there in all these 4 tables, right? So for the table 1, what are the employee ID we have? That means for the table employee, we have the employee ID. Let me check that as well. So let me first of all write to select star statement, right? And let me now run this 3 queries together. So in the first table, which is the employee table, we have the employee ID 1, 2, 3, 4, 5, right? In the second table, which is the employee department table, we have the employee ID 1, 3, 4, 5, 6. And then what we are getting in the union result of this two employee IDs is 1, 2, 3, 4, 5, 6. So as you can see, the union is actually doing the combination of all the records from these two tables. For example, if suppose that I want to also include the e name from this table and then d name from this table, is this possible? If I run this query, let's see what happens. You can see that as of now, I'm getting all the record set from these two tables, but this is actually wrong. Why I'm able to get this data? Because again, the data type of this is similar to the data type of this, right? Though the name is different, but the data type is same. So for the union to work, we should have the same data type. That is one thing. And the other thing is that there should be same number of columns in both the tables, right? But make sure that because this query is working, that doesn't mean that this is logically correct, right? So make sure that don't use something like that which is not logical correct. So here I should not be using the union like this, for and also I should not be using it like this. For example, here in the first part of the query, I'm writing employee ID, employee name. In the second one, if I'll just use employee ID, this will give me an error, because in union we should have same number of columns in the first table and the second table. The order of the columns should also be the same. That means here if you are following this order, below also we should be following the same order. The third thing is that suppose that is apart from employee ID, I want to use the other things as well, right? So for example, I want to use the designation here, and here I use the DPT ID. Will this work? Logically, again, this is incorrect because here combining designation with department ID doesn't make sense. Both are different things. But again, this query will error out as well. Why it will error out? Because the designation is of the type varchar while the department ID is of the type int, right? So the data type is also not matching. And that's why we are getting this error as well, right? So always whenever you are doing union, you have to combine on the basis of similar data type. Both columns should be using the same same logical values, and also the number of columns should be same between both tables. So these are the few things that we have to keep in mind while using union. The next is the union all operator, right? Union all is similar to union. There is not a lot of difference if we are going for union versus union all, but let me tell you what the difference is there. So there's simple logic here. Union equal to union all plus distinct. So that means when we are doing union, then we are first of all doing the union all. That means we are combining the values from two different data sources or two different tables. And after that, we are using the distinct on top of that. For example, uh, here we are making sure that if there's same values there in between both the tables, then we have to use that only once. We will be just removing or eliminating the duplicate values. So instead of union in this particular query, if I use the union all, let's see what happens after that. So you can see now what I'm getting is that I'm getting 1, 2, 3, 4, 5. Then after that 1, 3, 4, 5, 6. Because union all will not eliminate or it will not remove the duplicate values. And that's the difference between union and union all. So union all will give you all the matching record set from both the real set, while the union will give only the matching real set, and then it will also apply distinct operator on top of that. That means it will just put the distinct operator so that you are just getting the non-duplicate value, right? So that is the difference between union and union. Next is the insert into select state. Many times we want to insert data by selecting data from some other table, right? So in that situation, we use this insert into select statement. With SQL, you can copy information from one table to another. The insert into select statement copies data from one table to another, and to one table inserts into an existing table. Any existing rows in the target table are unaffected. We can copy all columns from one table to another existing table. How we can copy that? We can copy by using insert into table name, select star from table. So that is how we can copy data from one table to another, right? And again, if we want to copy only some column from one table to another, in that case, we can use insert into table name, and then we have to use the column names inside brackets. And then again, when you are using the select statement, you have to use those columns only. And that's how you can copy only few columns from one table to another, right? So this is the example. I had already talked about that in the past when we were covering the insert statement, that how many different types we can insert the data into the table, right? So that is that. With that, we are coming to a topic which is actually purely theoretical, right? And even this is not a universal topic, right? These things can change as per the company that you join. Everyone follows their own naming standard, but again, as we are trying to match the batch as per the what is going on in the industry, what are the things that industry is following. So that's why I want to cover this as well, but I will skip a lot of things because this is not this is just a type of introduction I want to do. I don't want to confuse with some
by putting up my naming standards and all. Whenever you will join a company, every company or every team follows a naming standard for the object. Why do we need this naming standard? So the reason for that is, for example, when you are in a team working, you have 10 other people who are also working, and then new people keep on joining in the team. If you follow a standard rule for naming the object or how the object should look like and all of that, then what will happen is that anyone who join news, or if he goes through that naming standard, he can actually get to know about all the things in the data. So he'll be able to get the information at a faster rate if we follow the naming standard. The other thing is that again, many people work on many things at the same time. So basically, suppose that if you are working on something and someone also has to take reference for from that. So if you have a particular naming convention for the object, then it would be easier for him also to understand that. So naming convention actually it actually helps in creating the simplicity of environment and all, right? So that is one of the thing here, and that's the reason we want to understand that how do you follow naming standards, what is the naming convention and all, right? So like in the previous queries that I was doing, I was following some convention for me as well. Like if you see, when I define the primary key in the table employee, let me show you. So here you can see, when I'm defining the primary key in the table employee or the employee department, I'm writing the name of the primary key in some specific order. Now this name can be anything, it will depend on the company where you are working. Maybe they are following some other naming convention. So naming convention is just about how to name our objects, right? And this is totally optional subject. If you want to, uh, just forget everything that I'm teaching here, that is also fine, because this is not a universal rule. But we need definitely a naming convention in anywhere we are working, that will help us to actually standardize everything and everyone can be on the same page at a fast rate, right? So I'll go with all these things quickly. So the main goal of adopting a naming convention for database objects is that you and others can easily identify the type and purpose of all the objects contained in the data. When reading these rules and guidelines, remember that consistent naming can be the most important rule to follow. So one of the thing is that whenever you are naming an object, and because multiple people are working together, it's important that we follow the standard rule so that others can also understand that what is this thing, what is the type of object it is, and all of that. So there are some general rules here for all database objects. I'm not going to read through all of this. What I'm going to do is that I'll send you this all details in a file, and you can just try to go through all of this. And if you have any questions after that, you can ask that, right? But for all database objects, we just suppose that I create a rule like will not have the database object name more than 50 characters, and we'll use only letters and underscore. We use letters as the first character of the name. Don't start name with underscore or numbers. Limit the use of abbreviations. Make the name readable, right? For example, if there's some table where you're going to store the employee data, it makes sense to give the table name as employee. If you give that table name customer, that will not make sense, right? That is bogus then. You should not be giving the name customer there. That is an employee table, right? So similarly, for each different objects, we'll have different type of rules. So as you can see for the tables, I have some rule 5 tools. For example, instead of using customers, we should be using customer table, right? The name should always be singular and all. Now this can definitely not make sense in case your organization is not following the same naming convention, right? So as I said, this is not a universal rule. You can create your own rules and then you can publish it somewhere, and then other people in your organization can take reference from there, so that everyone is on the same page. Naming convention is something which if everyone follows, then only it makes sense. Otherwise, if someone is not following, then definitely we'll have object with different type of names and all of that, which you would not be able to understand. So that's why naming convention is an important thing. So similar to tables, we have naming convention for columns, then we have for indexes, then constants, views, store procedures, functions, triggers, user defined data types, variables, and then we have some coding convention as well. So what is a coding convention? So like once we finish with naming our object, the other thing is that we'll write some store procedures and other stuff as well, right? So when you are doing the coding, you have to make sure that you are writing the code as per the performance guidelines and all, right? For example, whenever we are using the we are doing the coding, we should be using capital letters for keyword. We should make sure that the indentation is proper, and we should not be using select star, rather than we should be using the column names only. So also whenever we are querying the table, we should also try to write the appropriate schema from which we want this table, because sometimes we can have multiple schema, and in each of the schema this table exists. So it's important that we just keep that okay, from this schema I want this table. Also, we should be using aliases when we are using joins and all, right? For example, the employee table, if you remember, I gave it alias of E. Now everywhere I can use either that whole table name, or I can just use E to which will make the same sense as in as human resources dot employee or the DBO dot employee, right? Similar to that, there are some other things as well. One of the things that you see here is that set no count on. So what is set no count on? So one of the things that we should also do while writing our queries is that we try to make it more performant. That means it should not take forever to run the query, right? It should take just some seconds, not more than that. Now set no count on, it is used to improve the performance of the store procedure by reducing network traffic. How do we improve the performance here? Is that with set no count on, will not be counting the number of records which are affected by our query. By default, SQL Server has this mechanism that it will actually count the number of rows affected by each of these queries. And when you go to the result set, what you will see is that 4 record affected, 5 record affected, 100 record affected, and things like that. So in order for you to not print that thing, we can set the no count on. In that case, SQL Server will not put some effort in counting the data set and all. So that way you can definitely save some performance and all. So these are the different type of coding convention. Let me also show you the set no count on thing, because that is something which is a good concept. So for example, suppose that here is the insert statement. I want to insert some data into employee table again. I'll just try to insert one record here, and then I'll show you the same thing for this table. And here I will use set no count on. Okay. So let me first do this one. Suppose that here I'll give it a name F. Okay. So if I insert the value into the employee table, so this you can see that this value is inserted, and I got this message, one row affected. So SQL Server, whenever it does some operation, it will also by default uh, count the number of records that were affected by its query, right? That is the default nature. So definitely it takes some time to count the number of records. So it's better to turn it off. So now I'm going to insert the employee department 7 maybe, and I'll say this is a grocery department. Okay. And here I'm also setting the set no count on. So if I set this set no count on, you can see that what message I'm getting is that command completed success. I didn't get the number of records affected message. Why I didn't get that? Because I have the set no count on. So that we can use in the store procedures that we can create to improve some performance in terms of not getting the number of records that were affected by our query, right? So I guess this is all for today, guys. I don't have anything else for today. Tomorrow we'll start with a new concept. If anyone has any question from the today's topic or something before today as well, you can ask me now, or we will just end the class.